Hello, in this video I'm going to look at a very key algebra concept, two concepts actually, the difference between sorting and grouping. And if you've never had me as your teacher before, I like to use analogies in order to illustrate different examples in mathematics. So for this particular lesson I'm going to be using two different examples. If you've ever unloaded a dishwasher or sorted a basket full of laundry that's come out of the dryer, then you know about sorting. So sorting refers to organizing things by type. So you're going to be looking at some characteristic, some feature of those objects, and then deciding how you could separate them into smaller groups, for example. Grouping, on the other hand, is a form of sorting, but it specifically refers to organizing by number. So you're taking a group of objects, so it's organizing into groups based on number, or how many you have. So rather than looking at features like size or color, you would be looking at number, counting. Okay, so the first analogy or first example that I'm going to use for this is if I was unloading my dishwasher and I had this jumble of cutlery or silverware, I would start with sorting. That's the most efficient way to organize this in my drawer. I could just grab them all and throw them into a drawer and say, okay, that's done. But that's not really the way that usually it's done. So typically what you would do is you would look in your dishwasher and say, okay, I've got this jumble of stuff. I'm going to start by taking out the knives. All right, so those are organized in my drawer. And what's left? Oh, I can see I've got some spoons. That I've got some forks. So in my drawer in my kitchen, they're going to be organized by type. Okay, that's sorting. And I could summarize this. I could use algebraic notation and come up with a polynomial that represents this collection of objects by using some variables. So knife starts with a K, and I've got 4 of those, so I could say I've got 4 K's. I've also got 4 spoons, so 4 spoons, and I've got 4 forks. Okay, so this polynomial represents this collection of objects sorted by type, as opposed to just a jumble. Now, the convention when you're organizing a polynomial is to put them into alphabetical order. So I have to think about which of these, F, S, or K, comes first in the alphabet, and it is the F, so I would actually need to rewrite this as fork, knife, that's a K, and spoon, like that. And again, that's just for the purposes of making it as organized as possible. We respect alphabetical order, and that way it's predictable too. Okay, I'm just going to get rid of this little tail here. That's better. So, if I was being asked to set the table, that's where the grouping comes in. So sorting silverware. Okay, it's sorting. And then setting the table. So if I was setting the table, I have to think not just about what are the items that I have, what are the objects that I have to put on, but I have to consider them in groups, in equal groups. Okay, it would not be sufficient for me to just go and plunk 3 random things at every spot. So I can see I've got 3 groups of objects, and I've got 4 in each. So that means that I can create 4 place settings out of this collection of objects. In other words, I could have 4 guests sitting at my table. So when I set the table, I'm going to have a spot for the plate. I'm going to have a spoon on this side. I'm going to have a knife, and I'm going to have a fork. So every person will end up with one of each of the different types of silverware. So rather than representing that situation as 4 forks, 4 knives, and 4 spoons, I could represent that as 4 place settings, each of which contains a fork, a knife, and a spoon. So this is the reason that I refer to brackets as grouping symbols, because it accurately describes what's going on here. We've got 4 groups of 3 objects that are different. It's also referred to as factoring. That's one way of representing groups of objects. It's called factoring. Okay, let's look at another example. Move my cutlery here. So this time, the objects that I'm going to be considering are some random candies that I found in the cupboard. And I have 2 kids. And I'm going to look at how could I share these candies out in a way that is not going to create problems. In other words, I have to sort them and divide them fairly between 2 different people. So the first part of that process is the sorting, so sorting them by type. Okay. All right. So you can count those if you like. What I see here is I've got 16 of the mini eggs. I'm going to use an M for that. I've got 4 of the fuzzy peaches. And I've got 2 of these large Oreo eggs. So let's say 2 E's. And I've chosen the order that I'm writing them down so that it's alphabetical. So E before F and F before M. So my whole collection of candies, sorted by type, would be represented with this polynomial that has 3 terms, like that. And then because I mentioned I'm going to be dividing it between my 2 kids, I need to look at each of these values. Whew, thank goodness they're even. If they weren't, I would have just eaten one. I can divide it up this way. I can say I'm going to make 2 different piles. Each pile is going to have one of those large Oreo eggs. It's going to have 2 of the fuzzy peach candies, and it's going to have 8 mini eggs. Okay, so this is polynomial. Which simply means it has multiple terms in it, different variables represented. That's fine, because I had actually different objects represented. And then the second version of this is my factored or grouped this case into two groups. Hope that helps.